Azure Data Factory enables you to do hybrid data integration. Learn from Abhishek in this episode of Data Exposed on how. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Abhishek, who's a program manager on the Azure Data team. Thanks for joining us today.
Hey, Anna. Nice to meet you. So thank you for having me here, and look forward to finishing this recording.
Yeah, we're happy to have you on the show. And today we're going to be talking about Azure Data Factory, which is something we haven't really talked about on the show before. We're going to talk about how it relates to hybrid data integration and movement, and specifically Azure SQL and SQL Server. So before we get into it, I would love if you could start by sharing with us, what is Azure Data Factory?
Sure. So Azure Data Factory is a fully managed ETL service, and I would just want to call this out ETL, extract, transform, and load. And many people use this for data integration requirements because it gives you a rich set of connectors to ingest data, not just from the cloud sources, but from your on-prem sources as well. So think of it that you might have data across in different formats, maybe in your file systems or in your different relational data sources. And you can integrate them, all of them, including SaaS apps like Adobe, or we have a bunch of SaaS connectors as well. So you can integrate all your data from all those different sources and bring it onto Azure. So in this whole video, we will talk about loading data into Azure SQL Database. And one of few of the key value props of Azure Data Factory is it's hybrid, and it's quite simple to use. It's easy to use. It gives you a beautiful visual UI where you can click on buttons and then go ahead and configure all your transformation requirements or ingestion requirements. Just few clicks and then you're done. So that's easy to use, and it's pretty cost effective because you pay only for the time that you actually run your data pipelines on. And it's fully managed. You don't have to worry about management, the infrastructure, and so on. And it gives you 90 plus data connectors where you can use it with cross-cloud, multi-cloud solutions. If your data is on Google Cloud or Amazon Cloud, or if it's on a SaaS service provider, Salesforce, you can bring all those data onto Azure using Azure Data Factory. And you don't have to pay for per connector or something. So you just pay for your data pipelines. And it gives you an autonomous ETL. It gives you AI-based intent when you're doing copy jobs, ingesting data. It helps you certainly tweak up your performance in a more intelligent fashion.
Awesome. Very cool. And today you prepared some really interesting scenarios for us, a bunch of demos. So I'm really excited to see, what scenarios you have for us today.
Sure. So let's talk about some of the common scenarios that we see customers doing with Azure Data Factory. And one of the common scenarios is many data engineers and data scientists, they do deal with a lot of CSV and JSON files. And they require a solution of loading those into a relational database like Azure SQL DB. And this is the first scenario which we'll talk about. How you can use Azure Data Factory and load the data from your CSV, JSON, semi-structured data into Azure SQL database. And then second, we will talk about loading the data from another relational store. So you can copy between relational stores in Azure SQL DB using ADF. You can even copy CSVs and JSONs into Azure SQL DB, as long as you can do the schema mappings. And then we'll talk about how do we actually get this on-prem connectivity up and working as well. So let's start with the demo. So here's my Azure Data Factory. And once I'm logged into my Azure Data Factory, you can go ahead in Azure Portal, create a new Data Factory resource. And once you log into that Azure Data Factory resource, this is the screen, how it would look like. I'm in my Author tab, where you can start authoring your pipelines. And I click on this plus and start using a copy data tool. This is kind of a simplified tool for doing data ingestion. And I'm just going to click on a few clicks here. And it lets me select a source data set. So this is the most important part where you actually create a connectivity with your on-prem systems. I have already done that. And if you have to create a new connection, it's very simple. Click on plus new connection. And in this case, I'm loading data. In the first scenario, I'm loading data from a CSV into Azure SQL DB, and the CSV lies on-prem in a file. And since we're reading it from a file system, on-premise file system, I'm going to select this file system here and just select the right integration runtime. So I have an integration runtime set up on-premise to access the on-premise data. And we will talk more details about how to set this up later. But once you have this set up and I have this set up, I just select this, give it a host path where my data actually exists, and put in my credentials here to access the data, and hit this test connection button. And it says it's successful, which means I'm able to reach out to this particular data. That's great. Click on this create button, and it basically creates a connection to my file share, a file system where my data resides. And so we go on to the next screen, which is now specifying which particular data file do I want to read the data from. And I can actually browse and I can see what data exists. And I have 2 product files, which basically has list of products. And I want to load them into my SQL DB and probably into a products table. And I can have as many files as I want. But in this particular case, I have just 2 files. And I'm going to specify that recursively read these files, whatever number of files you have in this folder, and be able to use this as a source. You have other properties like last modified time. If you want to filter out data based on last modified time, you can pretty much do that over here as well. And this is where you specify the file format settings. And as I said, ADF will try and understand your data. It will try and do some schema queries and understand what schema your data looks like in, though it's in a CSV file, but you would see that it is able to read the file, list the file, and it has a first row as a header. So you can see, you can do a data preview over here, check here how your data looks like. This is how my data looks like. And then proceed with the next step, which is select the destination where you want the data to be in. And in this case, let's go ahead and select a SQL database. And I'm going to use the Azure SQL database to load this data into. And I'm going to select the same on-premise IR, which is going to access this particular Azure SQL database. Go ahead, select some subscriptions, server name, and the database, and hit on the test connection button again. So this is again validating the connection with the Azure SQL DB, and it says it's successful. I'm just going to click on this create button. It's going to save the connections. I'm going to click on next here and highlight a quick functionality in Data Factory. For example, in case if you don't have a table in your SQL database already created because you're loading it for the first time, then Azure Data Factory can help you create or generate those tables as well. So you can see that option that ADF queried the database. It understood that there's no similar table with the same name as the file name, and it gives you an option whether you want to manually specify an existing table or you want to create a new one. So we can quickly specify a new one and call it as products and click on next. And here's my schema. You can do schema modifications. So the best part of Data Factory is while doing this whole data movement, you can specify or remap schemas. So if you want to change product ID to byte or integer, you can pretty much do that over here. I'm going to not do anything. You can run some SQL scripts, pre-copy SQL scripts over here. You can define what batch size do you want to write. And these are some considerations which goes in when you're talking about performance. But for now, I'm not going to touch any of these values, and I'm going to click on next. You can also use Data Factory to do a consistency verification where it actually checks whether all the records have been copied, especially while doing large bulk data movements. It's pretty handy. Click on next, and it quickly goes and validates the whole environment, the connectivity between the file system and the Azure SQL DB, and it's already verified. Goes on, creates data sets, creates pipelines, and you can click on simply the monitoring pane and go to the monitor pane to see the progress of the pipeline.
Awesome. I really like how easy to use this is. I'm not really going to need to go to the documentation. I can just kind of follow along and figure out what I need to do.
Absolutely. And it takes a few seconds over here. And once, since this only has 43 records, it's just going to happen in a few split seconds. But the whole point over here is it happens. You can see a beautiful monitoring view, see how many records we dealt with, and the status of your particular copy. And just to do a quick validation of this particular copy job that happened, I would want to go and show you. Here's the database, and we can just refresh the tables, and you will see now DBO products actually appears. I can do a selection and even view and look into the data. So this is how easy it was to kind of load the data, populate the table, and then we can validate the data as well using Azure Data Studio, and it's right here. So here's the result. And now the second demo that I wanted to run through is being able to load the data from another database. So I also have a database, and I can run a similar pipeline. And this time around, what I will do is, since we know the steps on how to go about creating the connections, I do have connections created. I'm just going to leverage those to kind of quickly create a pipeline. So here's my data sets, which I have already pre-configured. Here's my SQL Server source. This is my on-prem SQL Server, and I'm going to select this, click on Next, and it's going to list down all the tables that this particular database has. You can write your own queries if you want to get some specific data, do some joins and stuff, but typically it gives you a beautiful UI. It lists down the tables. What I'm going to do now is select. You can do a multi-select, which is quite easy, and click on Next and specify if you want to do some schema mapping or changes in the schema. You can. This is the right step where you do it. But if you don't want to do it, it pretty much does or infers the schema and is able to map it to Azure or whatever sink you select. So we're good with the source. We selected these 5 tables. Click on this next button, go to the destination, and we're going to load this into the same database that we had earlier. So I'm going to do, here's my sync database. Click on Next. And it's trying to now detect if there is any table with the name client, occupation, and all these. And if it finds one, it's going to pre-populate those tables. If it does not, it'll give you an option of manually or automatically creating these tables. It's just going to create these tables automatically while loading the data. And we are good. So if you want to do remapping of columns or change the data types that you're mapping it onto, you can do it in this particular screen. And if you don't, you can leave it as is and click on Next. And here we go, another Next. It's now validating the environment, if the connectivity between the two source and the sink, it's all good, creating different data sets, pipelines, and running the pipeline. So here's the pipeline plane, and you have the for each iteration and the activity underneath it, which copies the file. And we have this for each created through the copy data that you saw. We actually authored this whole pipeline through that. And now you can go to the monitoring and monitor the status of this pipeline run, which we did, and see the status of it. So here we go into the monitoring. You have the ATT pipeline to correlate the values. Click on it, and it's going to show you the detailed status. So you will see this time around that it does create multiple copy jobs because we selected 5 tables. But in reality, you didn't have to create and configure each of these copy jobs. So you saved a lot of time, especially when you're copying data from, let's say, 100 different tables. It does come in really handy because you don't have to author 100 times and 100 different copy jobs, but you just copy job, you just author one of them, and then ADF takes care that it creates a beautiful control flow and iteration logic there so that it can help you with authoring these kind of pipelines very, very quickly.
This is awesome. I really like how it's able to kind of take a lot of the manual legwork out of it and also do it in an intelligent way. So it picks the new table names for me. I can edit them if I want. It picks a schema. I can edit it if I want. So it just makes it, really easy. Now, one question I still have is this self-hosted integration runtime. Can you tell me a little bit more and maybe even show us, what that is, how it works, or maybe how complicated it is to set up?
Absolutely. Before we go there, here's a quick validation of the data. Here's the list of tables that got created and the data in there. Now, so we are good with that. Now let's get back to how we set up this whole environment of the self-hosted integration runtime. And it's very easy. And you can do that setup in just a few clicks. You need to know that you still need some permissions to install a software on any one of your machines, and that's all what you need. But you can quickly go into this Manage tab over here, click on Integration Runtimes under Connections, and then click a new Azure Self-Hosted Integration Runtime. So you can use it this particular way. You can create an integration runtime on Azure, or you can create a self-hosted integration runtime. I'm going to select a self-hosted integration runtime over here. So when you click on this, it just gives you a way to create a logical integration runtime, and you can pretty much call this as self-hosted, just to be clear. And given a description, you can see the type is self-hosted, auto-selected, and then click on this Create button. So here's the integration runtime setup screen, and you have two options how to set this whole integration runtime on-premise. One is you can click on this Express install link. It is an Express install link, which basically will be a pop-up, and then you just need to click and it'll download the whole integration runtime and set it up manually for you. You don't have to do anything on that part. And so the other way around is a manual installation, where you can actually download the bits and then register the bits with one of these authentication keys. And this is the keys which kind of binds it to this logical IR, which you just now created. And then you can start to run your jobs completely transparently. You don't have to worry about this. Right now, you can monitor the nodes, the number of nodes once you set it up. We haven't had any nodes set up, and hence it doesn't appear here. But you can see that there are other configuration options like auto updates, which means Windows or Microsoft will take care of making sure that all the software is always updated. So whenever there's a new update on new connectors or new bug fixes that we keep doing, it'll automatically roll out to your machines. It's a kind of a one-time setup that you do, and you can pretty much be good with that particular setup. So here we go. We click on this, which generates or downloads a local file over here, which I'm going to quickly show you. And you can run this particular file to kick off the installation. And the installation process is going to take around 2 to 4 minutes. Great. So here's our setup, which just successfully completed. So it went into installation and then registered this whole node as well. And you can see there's a node name over here, which shows up. And I can click on close. And I can quickly validate this by going into my UI. And if I now go back here, you can actually see there is a new node. It's going to show up here in a few seconds. It does take a few seconds to kind of refresh, but it'll do. And you can already see the logical name, which already appears here. And you can monitor each one of these nodes using the monitoring UI. You can see now it's up and running. This is self-hosted integration runtime. And you can anytime find out the nodes, the versions it's running on, and things like that. So that's about it, how you set up this infrastructure using which you can access on-premise data.
Awesome. Thanks, Abhishek. This has been really interesting. I've seen, 3 new things I hadn't seen before, and all seem like pretty easy for me to start to use, right after this. So that's really great. As things get more complicated and we start looking at data integration type of considerations, can you give our viewers some insights of what they should consider?
Sure. With respect to the data movement considerations, A few things which I want to call out here is while you are designing your data loading or data ingestion pipelines, customers do have considerations around whether they want to do it one time or they want to incrementally keep doing this every hourly on an hourly or on a daily or a weekly basis. It depends on what your requirements are, but you can pretty much achieve both these patterns. You can do one-time historical load. The whole demo that we actually did was more like one-time load. But if you want to do anything incrementally on hourly basis, every 15 minutes, you can pretty much do that. ADF as an orchestrator can orchestrate your jobs every 15 minutes, every 5 minutes, based on whatever time intervals you need in terms of moving your data, replicating your data, and so on. So that's one of the considerations in terms of data loading. And you can set up both of these patterns with Azure Data Factory. And then we talked about integration runtime management. And you saw that this was a manual setup where we actually clicked on this button. It installed this whole integration runtime. And you can scale it out as well if the need be. And to understand if there is a need, we have exposed alerting metrics to Azure Monitor for CPU, memory, queue length, average queue time. And all these metrics helps you understand the resource contention issues whenever it happens. And when it happens, you will get alerted using Azure Monitor. Once you set up this alerting metrics in Azure Data Factory, you can set all of those up using Azure Data Factory. Now, once you set these alerts, and if there are too many jobs, for example, running on a single self-hosted integration runtime, and your CPU and memory is running lower, you will get an alert. The action on you is to come out and make sure you are able to scale out these nodes. You're able to install this same integration runtime across on multiple nodes. You can go up to 4. You can even scale up by, if you have a lot of small jobs running on these self-hosted integration runtime, which are not particularly taking or consuming a lot of CPU and memory, but yet it is consuming all the slots available. For example, 8-core machine could have up to 16 slots. And if you're very small jobs which you are running right now and it's consuming all the 16 slots, yet your CPU and memory is not even 50% utilized, that is where you can use up the scale up mechanism, and you can increase the concurrency on the self-hosted IR nodes to maybe a higher number, let's say 32. Now, this will give you ability to kind of utilize your CPU and memory better where you have set up your self-hosted integration runtime on. So pretty much at a high level, these are some of the considerations which should go in while you are creating these pipelines, and to make it more performant and scalable. These are some of these considerations here.
Awesome. Thanks so much, Abhishek. This has been such an interesting session. I've learned so much about Azure Data Factory. We're going to put some links in our description for our viewers to go learn more. So we encourage you to go check them out and give us a like or a comment on what you're doing with Azure Data Factory. And we hope to see you next time on Data Exposed.